Hi there. Let's deal with topic 7, which is looking at chemical reactions and how we might control them by slowing them down or speeding them up. So a chemical reaction is a process in which one or new substances are produced as a result of a chemical change. And we've talked about physical and chemical changes before, and we know that there's lots of indicators of a chemical change. One is heat and light being given off or absorbed. The other would be bubbles being produced, which might indicate a new gas is formed. Another example of a chemical change might be things like a color change, which might indicate you've made a new substance, or quite possibly a new solid or precipitate is formed. In a chemical reaction, we always have the ingredients or the reactants, and we have the products or new things that we've made. And this arrow is usually used to stands for produces. So let's just check, how does an equation indicate a change in the identity of the reacting substances? The chemical formulas of the reactants are different than the chemical formulas of the products. And how did yellow and green reactants combine in a chemical reaction? Well, let's look at that. Here's a chemical equation. The symbol given before and after. So we have reactants, magnesium oxide and carbon, and we have products, carbon monoxide and magnesium. And so that's how the word equation looks, and this is how we would read it. So let's look at this. 12 ounces of dough, 4 ounces of mushrooms, so on is a recipe for making pizza. So if we wrote a chemical reaction, these would be our reactants, and this would be our product. These are called word equations. Here's another one. Ammonia, NH3 plus oxygen produces NHNO, so nitrogen monoxide and water. But what about these things? We've talked about these before, 5, 4, etc. What do they mean in a chemical reaction? Well, they stand for the number of molecules of substances reacting. So 4 molecules of ammonia reacts with 5 molecules of oxygen to produce 4 molecules of nitrogen monoxide and 6. So let's say instead of 4, we had 8 molecules of ammonia. How many molecules of oxygen would be needed? 10. How many of nitrogen monoxide? 8. And how many of water? 12. Or let's say we had 2 molecules of ammonia. That would be 2.5 molecules of oxygen, 2 molecules of nitrogen monoxide, and half or 2 molecules. So these proportions work. Again, here's our evidence of a chemical reaction, and let's focus in on heat or light. There are 2 kinds that are categorized here. One is called exothermic, which means it heats up or gets hotter. The reactants are hotter than the products, are hotter than the reactants. Or the other is endothermic, which means it cools down, which means the reactants are cooler than the products. Here's an example of a type of chemical reaction. It's a combustion reaction. And iron plus oxygen produces iron oxide. Heat is one of the ingredients needed here on the reactant side, so endothermic. However, here's another one. This one's combustion. Wood and oxygen produce carbon dioxide, water, and energy is released. If energy is released, it's going to heat up, and therefore it's exothermic. We talked about coefficients, and just a reminder about the law of conservation of mass. So the mass of all the atoms here must equal the mass of all the atoms here. We did hot potato, cold potato to figure out how a exo or endothermic reaction would work. Let's go on to controlling chemical reactions. In this, we're going to talk about enzymes, and we're going to talk about how we might control the rate at which a reaction occurs. For example, bananas, when they ripen and turn yellow, that's a chemical reaction. How could you slow it down? Or food spoiling is a chemical reaction. How could you control its rate? Oops. So chemical reactions, two reactants, and a new thing is a product. One way we can control chemical reaction is through something called collision theory. Collision theory says that the more collisions in a system, the more likely to make products or new things. So low temperature, the particles are moving slowly. Higher temperature, there are more collisions, and therefore, quite possibly, you're going to get more products. So temperature, the higher the temperature, the faster the reaction. The next is surface area. See these two? This has low surface area, and this has high surface area. Which one of these two would react faster? The one that is high, lots of surface area, because particles can collide easier with them. In this one, you have to tear away the layers to get at the middle, and therefore it takes more time to react. So the more the surface area, the faster the reaction. Next, concentration, which has to do with the numbers of reactants. So for example, in this reaction here, we have blue and red, but we only have two red. So if you remember my reaction before, blue and red make green. Once we run out of red, so those two will react to make a green, those two react to make a green, that's it. That's all that can happen. However, if we increase the concentration of red, then we make more green. So the higher the concentration of the reactants and the more products we can make. The other thing that we can do to speed up chemical reactions is to introduce a catalyst like an enzyme. An enzyme is a catalyst. There are enzymes in our bodies to help speed up chemical reaction. For example, our bodies in our mouth, we have a salivary amylase. Amylase helps speed up the breakdown of sugars in our mouth. So how does an enzyme, or how does a catalyst work? It provides a special location for the two reactants to meet, which speeds up the process of making new products, in our case green. So the catalyst isn't used up. Once these two meet to create a green product, then the catalyst can come back and it can help two more blue and red meet again. So catalysts are not used up. They provide kind of a spot for the reactants to quickly get together to make a product. So here are some enzymes. See, here's the enzyme working to help these two join together to make the product. And there are lots of enzymes in our body. There's amylase, which helps convert starch into shorter chain sugars. People who are lactose intolerant means that they don't have the enzyme lactase, which means they have a hard time breaking down milk sugar. So let's review. We've talked about 4 ways that we can control chemical reactions. Change the concentration, change the temperature, add a catalyst, or change the surface area. So let's look at this. Let's say we have calcite reacting with hydrochloric acid. We could react it in large chunks or small chunks. Which one would occur faster? This one, because it's smaller surface area. We could react sulfuric acid with lead, 5% or 10%. Which would occur faster? The 10% concentration, because there's more reactants available at a higher concentration. we could react this where we stir it or we don't. Stirring it, according to collision theory, makes the combining of the particles occur faster. And finally, we could react iron with copper 2 sulfate at 65 or at 25. Which one would occur faster? The one at 65, it's a higher temperature. We did this lab where we had different temperatures, 10 degrees I think, and 25, and then a really hot one, 50. And we found out that the rate of reaction went up and up and up with higher temperatures. And so there's a quick overview of chemical reactions, topic 7.